In this video, we will design a foundation through a hypothetical geotechnical case study representing the Greater Cairo region of Egypt. Our project is a 7-story reinforced concrete residential building. Soft clay layers and a high groundwater level are present below the structure. At first, a shallow raft foundation may seem suitable. But will it really be sufficient? First, we will evaluate the shallow foundation. Then, we will compare jet grouting, deep mixing, and board pile foundation alternatives technically and economically. The soil model is created by evaluating data from boreholes, laboratory tests, and field tests from an engineering perspective. This table includes the strength, deformation, and consolidation parameters for each soil layer. These parameters form the basis of the bearing capacity, settlement, and other geotechnical analyses. Now, let's define the soil materials. We will enter the engineering parameters used in the analyses for each soil layer into setaf. I select sand as the material type. I enter fill as the material name. I enter the natural and saturated unit weight values. I move to the Mechanical Properties tab. I enter the effective cohesion value. I enter the effective friction angle. Now, let's continue with the effective elastic modulus. After entering the effective Poisson's ratio, I click Calculate to calculate the undrained elastic modulus. Next, I enter the undrained shear strength. I click Apply. We will add the other materials required for the soil profile in the same way. The software uses only the soil parameters required for the selected analysis type. We will also define consolidation parameters for this clay material. I right-click the material and open the Program Options menu. The consolidation properties are now active. I enter the natural void ratio. I move to the Mechanical Properties tab. Now, we enter the soil parameters used in effective stress analyses. Let's define the total stress parameters. We enter the consolidation parameters. I continue defining the other soil materials in the same way. For the clay layers, I also enter the consolidation parameters. Now, all materials are defined. Now, let's define the soil profile. I click Soil Profile in the Define menu. In the window, I double-click the default borehole one to open its properties. I enter the groundwater level. I double-click the default layer to open the Layer Properties window. I enter the layer name. I enter the layer elevations. I define the drainage condition. I will define the fill, sand, and gravel layers as drained, and the clay layers as undrained. The number of sublayers defines how many calculation points the software uses within a layer during deformation analyses. Now, I assign the fill material to the layer. Let's define the other soil layers in the same way. Now, the soil profile is defined. Let's define the foundation. I click Foundations in the Define menu. I double-click the default foundation to open the Foundation Properties window. I enter the foundation base elevation as -2.5 meters. I select Polygon as the foundation geometry. I move to the Polygon Foundation tab and define the polygon points. Now, the polygon geometry is defined. I move to the Shallow Foundation Properties tab. I enter the LX and Ly values. I move to the Load Properties tab. I enter the average base pressure. I click the button below to calculate the P load. I change the default MX and VX values to 0. Then, I click Calculate to calculate the net base pressure. Now, let's click G++ to add a settlement point at the geometric center of the polygon foundation. Now, the polygon foundation is added to the model. I change the position of the borehole in the model. I click Foundation Analysis in the Analysis menu. I move to the Shallow Foundation Bearing Capacity tab. After selecting Total Stress Analysis, I click Bearing Capacity Analysis. You can select the variables you want to see in the calculation table from the list on the right. The factors of safety show that the shallow foundation has sufficient bearing capacity. I move to the Analysis Summary tab. Here, I select Total Stress Analysis and the foundation. Then, I click Analysis Summary. Next, I click Bearing Capacity Report to create a detailed report with the calculation steps. I enter a report name and save it. The report then appears on the screen. In the same way, I create the report for effective stresses. I move to the Settlement Analysis tab. Then, I click Settlement Analysis. As you can see, the software calculates the total settlement as 17.8 centimeters. It also shows the immediate and consolidation settlements separately. Now, let's examine the stress increases transferred from the foundation to the soil and check whether the model depth is sufficient. I select the option that shows the net stress increases. Then, I click Stress Increases. Now, we can see the stress increase diagram below the foundation on the 3D screen. The stress increase at the bottom of the profile shows that the model depth is sufficient. Now, let's define the parameters required for the consolidation rate to obtain settlement time graphs. I change the time unit to minutes. I click Materials. I double-click the soft clay material to open its properties. On the Mechanical Properties tab, I enter the T50 and T90 parameters for 50% and 90% consolidation. I enter these parameters for the other undrained clay materials in the same way. After entering the parameters, we click Calculate to calculate the consolidation coefficients. Now, the consolidation parameters required for settlement time analyses are defined. Before viewing the graphs, I change the time unit to years. I return to the Foundation Analysis window and click Settlement Analysis. After the analysis, I move to the Consolidation Rate tab. I enter the consolidation period as 80 years. Then, I click Settlement Analysis again. Now, the settlement time graphs are available. According to the graph, consolidation is completed in approximately 62 years. I click Save as Image and save the graph. The analyses show that the shallow foundation has sufficient bearing capacity, but it does not satisfy the settlement criteria. To reduce settlement, I will improve the foundation soil with deep mixing columns. Now, let's define the deep mixing parameters for the material. I right-click the window and open Program Options. Here, I activate the Additional Data option. After entering the natural water content, natural unit weight, and specific gravity of solids, I click Calculate. Now, we have determined the natural water content, dry unit weight, and saturated unit weight required for the mix calculations. Now, I move to the Deep Mixing tab. Because the fill layer is above the groundwater level, I select Wet Mixing. Then, I enter the column compressive strength. The software calculates the required mix properties, slurry quantity, and binder quantity for the target compressive strength. I enter the required physical properties for the soft clay material and click Calculate. On the Deep Mixing tab, I select Dry Mixing because this material is below the groundwater level. After entering the required column strength, I click Calculate to calculate parameters such as the column unit weight and elastic modulus. I define the physical properties and deep mixing parameters for the other materials in the same way. Now, the physical properties and deep mixing parameters are defined for all other materials. Now, I open the Foundation Properties window and define the deep mixing columns. I move to the Deep Foundation, Ground Improvement tab. I select the Deep Foundation, Ground Improvement option to activate this tab. I keep the rigid column type as deep mixing and the column diameter as 0.65 meters. I enter the column length as 12 meters. Now, I am on the Polygon Foundation Geometry tab. I enter both SX and psi as 2.7 meters. The columns are placed according to this spacing. I enter the offset value as 2.3 and click Add Group. Now, the rigid column group is added inside the Polygon Foundation. I use the Ctrl plus a shortcut to open the Foundation Analysis window. Then, I click Settlement Analysis. As you can see, the total settlement decreases to 3.3 centimeters after ground improvement. I move to the Rigid Column Bearing Capacity tab and click Bearing Capacity. As you can see, the bearing capacities of both the single column and the column group are insufficient. I right-click and open the Foundation Properties window. I increase the column length to 13 meters. Then, I click Bearing Capacity. Now, the factors of safety are sufficient. Now, let's create the material report containing the mix calculations. I save the report. This report includes all details of the mix calculations. I move to the Analysis Summary tab. I select Total Stress as the analysis type. Then, I select the foundation and click Analysis Summary. Next, I click Bearing Capacity Report and save the report. This report presents the bearing capacity calculations for the shallow foundation, deep mixing columns, and combined system in detail. Now, let's create the table-based general foundation report. For shallow foundation bearing capacity, I select Total Stress and click Report. I save this report in PDF format. Now, I move to the Deep Foundation Drawings tab. I click Structural Properties and then Deep Foundation Drawing. Now, the foundation project drawings are created. I save the project drawings in DWG format. Now, let's create the quantity takeoff. The deep mixing design is complete. Now, let's define the material properties for jet grouting. I open the Fill Material Properties and move to the Jet Grouting tab. Here, I use the correlation buttons to calculate the compressive strength, unit weight, and elastic modulus based on the water-cement ratio and material type. In the same way, I enter the jet grouting parameters for the soft clay material. I also define the jet grouting parameters for the other materials. Now, the jet grouting parameters are defined for all materials. I open the Foundation Analysis window. I right-click and open the Foundation Properties window. I select jet grouting as the rigid column type. Then, I click Settlement Analysis. The jet grouting columns reduce the total settlement further, down to 1.7 centimeters. I move to the Deep Foundation, Ground Improvement tab and click Bearing Capacity. The calculated factors of safety are sufficient. I move to the Analysis Summary tab and create the detailed bearing capacity report. I save the report. I also create the general foundation report. Let's save this report as a PDF. Now, let's select reinforced concrete piles as the rigid column type. I reopen the Foundation Analysis window and right-click to open Foundation Properties. Here, I select reinforced concrete piles as the rigid column type. Then, I click Settlement Analysis. As you can see, the total settlement decreases further to 1.1 centimeters. I move to the Deep Foundation tab and click Bearing Capacity. As you can see, the factors of safety are sufficient. I move to the Analysis Summary tab and create the Bearing Capacity report. I save this report as a PDF. Now, let's create the table-based general foundation report and save it as a PDF. Finally, let's create the project drawings for the reinforced concrete piles. I move to the Deep Foundation Drawings tab in the Foundation Analysis window. After selecting the concrete and steel grades, I click Structural Properties and then Deep Foundation Drawing. I save the drawing in DWG format. Now, let's create the quantity takeoff. You can calculate pile reinforcement, concrete, drilling, and other quantities and export them to Excel. In conclusion, the shallow foundation has sufficient bearing capacity, but the total settlement is calculated as 17.8 centimeters. The total settlement decreases to 3.3 centimeters with deep mixing, 1.7 centimeters with jet grouting, and 1.1 centimeters with reinforced concrete piles. We completed the analyses, reports, and project drawings for all three solutions. Although reinforced concrete piles provide the lowest settlement, deep mixing columns are more suitable in terms of performance and economy. Thanks for watching.